Assalamualaikum warahmatullahi wabarakatuh, ladies and gentlemen. So for this opportunity, we are from want to present our methodologies about assessing hazard and risk at laboratorium. So I want to introduce our group that is I am Adam Priambada and Maulana, Nadira, Nurul, Fathiya, and Novika Putri. So our material is about first console information source, evaluating the risk of toxic chemical laboratory, assessing the hazard of flammable material, reactive and explosive, assessing physical hazard and assessing biological hazard. The first material I will deliver this about console information source. Hazard identification include the identification of aspects of company operation of environmental impact on nature and the surrounding population in the company. Areas concerning several elements such as land, water, air, and energy source, and another natural resource including aspect flora fauna in the company environment. In the risk assessment, the laboratory user should check their plan for proposed experiments and identify unknown chemical. Many source power which can assist in assessing the hazard and risk of material chemistry in laboratory. The most recognized resource universally include the first, a chemical health plan. Second, material health data set or MSDS. C and next is Laboratorium Chemical Safety Summary (MSDS). Fourth, International Chemical Safety Card (ECSC). And the last is Global Harmonized System for Hazard Communication or GHS. And the next material will be reviewed by my friends. This is Emre Maulana. Emre Maulana, time is yours.
Okay, thank you for Mr. Adam Priambada for giving me a chance to explain about evaluating laboratory chemical risk. Toxicology is the study of the back effects of materials chemistry to living system. All laboratory user must understand the basic principle of toxicology, which is no substance is completely safe, and all chemical can toxic effect even excessive doses, and learn to identify toxic chemical as well as corrosive. The step for evaluating the risk of using toxic chemicals are no hazardous chemicals, such as acute toxic chemicals, corrosive, irritant, allergen, asphyxiant, neurotoxin, and carcinogens. In assessing the hazard of flammable, reactive, and explosive materials, in addition to the harm caused by the toxic effect of chemicals, assessment risk must consider the hazard of chemicals because of its simplicity burn, reactivity, explosive, and flammability. The characteristics of the ease of burning include flash point is the lowest temperature at which a liquid has its vapor pressure to form a mixture which reacts with the surrounding air liquid surface. The degree of hazard associated with easy liquids fire also depends on other properties, such as the point of ignition and its boiling point. And the second, ignition temperature is the minimum temperature required for initiating or causing self-combustion without depending on a heat source. The lower the ignition temperature, the more large potential for fires triggered by the laboratory equipment. The cause of cognition, spontaneous combustion occurs when a substance reaches its ignition temperature without the heat from outside. We must always consider the possibility of self-combustion, especially when storing or disposing of materials. The example of materials susceptible to self-combustion includes rags, greasy, dust piles, organic material mixed with strong oxidizing agents such as nitric, chloric, permanganate, peroxide, persulfate, and alkali metal like sodium and potassium. The reactive water is the material that react violently with water, like alkali metals. Many organometallic compounds and some hydride react with water to generate heat and easy hydrogen gas burn, which ignites or combine explosively with oxygen in the atmosphere. Some anhydrous metal halides like aluminium bromide, calcium oxide, and non-metal oxides such as sulfur dioxide, as well halides and like phosphorus pentachloride, react exothermically with water. This causes a strong reaction if the cooling water is not sufficient for remove heat generated. And the last one is explosive. Explosivity is a chemical compound or a mechanical mixture that is, if subject to vibration, impact, and friction, will experience changes chemistry quickly to give rise to gas. This provision covers materials that are explosive or burn quickly. For example, reacting hydrogen and chlorine will explode easily if exposed to light. Okay, that's all from me. I turn back to moderator, to Mr. Madam.
Thank you, Maulana. And the next material about symbol assessing the toxic risk of certain laboratory chemical will be followed by Nadira and Fathiya. Nadira, time is yours.
Thank you to the moderator for this opportunity to explaining the presentations talk about assessing hazard and risk at laboratorium. So we're going to talk about the science. Thank you to the moderator for this opportunity to explaining the presentations talk about assessing hazard and risk at laboratorium. So we're going to talk about the symbols, the examples of the symbols that usually occurs in the laboratory. The first symbol means that the chemical compound will easily explode. The second symbol means that the chemical compound will easily burn or it is flammable. And the third symbol means that the chemical compound were oxidizing. Then we're going to talk about assessing the toxic risk of certain laboratory chemicals. The first step in assessing the risk of a planned experiments is identifying the chemical which ones will be used, which are potentially hazardous substances. The sections explain how assess the risk associated with a particular class of toxic chemicals. Chemicals used in the laboratory can be grouped into several different classes of toxic substances. The first group were acute toxics. Acute toxics is the ability of a chemical to cause harmful after effect one-time exposure. Acute toxic material can cause local toxic effect systemic, or both of local toxic effect and toxic effect systemic. This class of toxins include corrosive chemicals, irritants, and allergens or sensitive. The most common chemical with a high level of acute toxicity encountered in the laboratory, among others, such as acrolein, nickel carbonyl, arsine, nitrogen dioxide, chlorine, osmium tetraoxide, diazomethane, ozone, and many more. Irritants are non-corrosive chemicals that have an inflammatory effect, for example, swelling and redness. Corrosive substances are solid, liquid, or gaseous substances that destroy living tissue by action chemical in the area in contact. The corrosive effect does not only occur on the skin and eyes, but also in the respiratory tract, and if it is ingested, The corrosive effect would occur in the gastrointestinal tract. Chemical allergy is the immune system's river reactions to a chemical. Allergic reaction it is caused by prior sensitizations to the chemical or substance chemically similar structurally. The sensitivity of each person to laboratory chemical varies widely. Women work with known allergens, follow laboratory policies on handling and control. Asphyxiation is a substance that interferes with the delivery of an adequate supply of oxygen to the organs of the body which is vital. The brain is the organ most susceptible to oxygen deprivations, and exposure to asphyxiation leads to rapid fainting and death. Acetylene gas, carbon dioxide, argon, helium, ethane, nitrogen, methane, and butane are common assumptions. Neurotoxins have detrimental effect on the structure or function of the central or peripheral nervous system, which can be permanent or temporary. Some of the chemical neurotoxins include mercury in the inorganic and organic mercury, organophosphate pesticide, carbon disulfide, xylene, trichloroethylene, and xan. Reproductive toxins are substances that cause chromosomal damage or mutagens, and substances with a lethal or teratogenic or deformations effect on the fetus. This substance causes problems in various aspects of reproductions, including fertility, pregnancy, milk productions, and performance reproduction, and can affect both men and women. Toxin malreproductive in some cases causing sterility. Many are reproductive toxins is a chronic poisons that cause damage after repeated or prolonged exposure, long latency, with effect that becomes evident only after a long latency periods. Developmental toxins act during pregnancy and cause adverse effects on the fetus. When women are exposed to chemical, generally the fetus is also exposed because the placenta is very poor chemical barriers. Development poisons has the greatest effect during the first trimester of pregnancy. That is a presentation from me. I would give it back to the moderator.
That's all about our material today. Thank you, Nadira, for the explanation. And the next material about assessing physical hazard and assessing biological hazard will be referred by Novika Putri Abdalia. Novika, time is yours.
Thank you, Adam. The next is carcinogens. Carcinogens are substances that can cause cancer. Carcinogen is a chronically toxic substance. There is the substance that causes damage after repeat or long-term exposure, and the effect may be apparent after the latency period long. Carcinogen is a patient that is very dangerous because has no immediate visible harmful effect. The next material is assessing physical hazard. The first physical hazard is compressed gases. Compressed gases can expose workers to both mechanical and chemical hazard, depending on the gas. Hazard may be caused by the flammability, reactivity, or toxicity of the gas, from possibility of asphyxiation, and from the compression of the gas itself, which can cause it to rupture, tank, or valve. The next is high pressure reaction. Experiment carried at pressure above 1 atmosphere can cause explosion because equipment failure. Hydrogenation reactions are often carried out at higher pressure. A potential hazard is the formation of an explosive oxygen and hydrogen mixture and the catalyst reactivity or pyroporicity. The use of supercritical fluid can also cause high pressure. Next is electrical hazard. The laboratory can eliminate the danger of death from electric shock from instrument, device, and other electrical equipment if proper precautions are taken. However, it is possible the occurrence of blood injury or death from electric shock is very large if the engineer work, care, and personal work practice are not exercised with care. All laboratory personnel should know how to turn off the power to burning equipment by means of a disconnect switch, power supply, and or circuit breaker switch. Next is frequency hazard. There are first is radio and microwave radio frequency, and microwave are used in ovens and MRF furnace induction heater, and microwave ovens occur in the range of 10 to 300,000. Next is extreme overexposure to microwave can cause cataracts, sterility, or both. Next is the laboratory should use microwave oven designed for laboratory or industrial use. Use of metal in microwave oven can cause electric arc and their occurrence, fire or explosion if any of the young solvents have burned. Next is superheating of liquids may occur. The lid of the fuel and other material used in the oven can cause an explosion as the pressure builds up in the fuel bottle. Next is the wrong plastic container can melt. And this the other danger, like some of the most common injuries in the laboratory are hazard from broken glass and overmet slip trip or wrong lifting. Next is general workplace hazard also occur in laboratories. For example, laboratory personnel may suffer repetitive injury or back muscle injury. This problem need to be recognized and controlled so as to reduce work injury. Biological hazard assessment, namely the risk assessment for biological toxin, which is where the assessment is the same as in assessing the risk of the chemical. It is based on potential dose of poison use and procedures for use of the poison. Biohazards are a problem dealing with microorganisms and materials that is contaminated with microorganisms. These hazards usually appear in clinical and disease research laboratories, contagious, but may also appear in other laboratories. The assessment of the risks of biological hazard need to consider a number of factors, namely manipulating the organism, like the organism change from the original. So that's all from me. Uh, I give back to moderator.
That's all about our material today. That's about assessing hazard and risk at laboratorium. I hope you are enjoy about our material and can increase your knowledge about laboratorium. I'm Madam Raihan Priambada as a moderator. Sorry if I got a mistake. And Assalamualaikum warahmatullahi wabarakatuh.